Now, some primitives, they're not as straightforward as those elementary that we have seen, but all of them have this um, form, right? You have the derivative of f at g times the derivative of g, right? So this follows this the chain rule, right? You have f at g, the f composed with g, right? The derivative of this is f prime at g times the derivative of g, right? So if you have this form, it's easy to go back to the original one, right? So because it's easy, we call these immediate integrals or primitives, right? And some example of those are, for instance, if you have g prime divided by g, okay? The primitive of this is the logarithm of the absolute value of g plus c, right? Always a constant because you never know. You have the primitive of g prime divided by g squared. This is the arctangent of g, right? Plus a constant. Now if you have g prime times g to the alpha, right? Then this is equal to g to the alpha plus 1 divided by alpha plus 1 plus c. Okay, you see, right? In all of these cases, if you differentiate this side, you get this, right? So it's easy to see. And then, for instance, g prime divided by the square root of 1 minus g squared is the arcsine of g. Okay, some examples of this. Okay, so let's see some more examples of immediate primitives, okay, and how to compute them. So for instance, let's see, we have the tangent, the primitive of the tangent, right? And don't say it's 1 over the cosine square or something like that, right? So the primitive of the tangent, what we have to realize is that this is the sine divided by the cosine. And so remember that we have just said that we have a primitive of this form is the logarithm of the absolute value of g, right, plus c. Now in this case, we have g, right? G is the cosine, and g prime is minus the sine, right? So this is almost this primitive. So this is just minus, we multiply it by minus 1, and then we get this. And now this is the logarithm of this, the cosine. So this is minus the logarithm of the absolute value of the cosine plus c. Okay, that's the primitive of the tangent. Okay, and you can see easily that using the same argument to the cotangent, which is the cosine divided by the sine. Now in this case we have the sine here, and the derivative of the sine is the cosine, so this is directly the logarithm of the sine. Okay. Okay, so remember these two, or if you don't remember them, at least remember how to find them easily. Okay. And then we have another interesting example, which is more difficult, but it's interesting to compare with this. So this is the primitive of the second. Okay, and the second, remember, is 1 over the cosine of x, right? Now here it's kind of similar from before, right? But we lack the g prime on top, so we're going to want to do some manipulations here in order to get something that is the logarithm of something. Okay, so bear with me, right? The derivative of the second, right, is going to be the cosine squared, right? And then we have minus this derivative of this, so minus the sine, right? And this is sine divided by cosine, the tangent, times the second, right? So this is sine over cosine times 1 over cosine, right? Now, but the derivative of the tangent, we know, is 1 over the cosine squared, right? Or in other words, the second squared, right? So if we add these two, right? We have the derivative of the sum between the secant and the tangent. We have let's see, the tangent times the secant plus the secant squared, or in other words, we can take common factor secant squared, and we have, sorry, not secant squared, sorry, secant only, and we have the tangent plus the secant, right? But wait a minute, this and this is the same, so we can say that the secant is equal to the secant of x plus the tangent derivative divided by the secant plus the tangent. But now the primitive of this, if we compute the primitive, right? The primitive of this is just the logarithm of this, right? Of the absolute value of this. But this is exactly equal to the primitive of the secant, right? So if we write it here, this is the logarithm of the absolute value of the secant plus the tangent plus c. And you can also write this, if you want, this is 1 plus the sine divided by the cosine, okay? Both ways are correct if you don't like one of the two, right? 1 plus the sine, okay? So, yeah, you're not expected to come up with this kind of reasoning, but just so you understand how to compute this thing, okay? And so that's an interesting, you'll see it's going to be a very interesting primitive to know in some of the problems. And so knowing this, it's easy to see that this is going to be, this is the primitive of the cosecant, right? It's 1 over the sine of x. So I leave it to you to try it at home to prove that this is equal, the primitive of this is equal to the logarithm of the cosecant plus the cotangent, right? Or in other words, you can write it like this, the logarithm of the sine divided by 1 plus the cosine, okay, plus c. Okay?